Hello and welcome back to more geometric sequences. Okay, so for the last three examples that we have here, 4, 5, and 6, my suggestion is that you pause the video and that you try these next three on your own, and then you use the video to check to make sure that you got them right. And if you didn't, you can see how I did them. Okay, so I suggest you pause the video here, try the last three, 4, 5, and 6, and then come back to the video and then check your answers with what I did. All right? Okay, so I'm going to start here, though. For number 4, I see 2, -6, 18, and -54. So I'm looking for a pattern. It looks like that I am multiplying by -3. Now, again, if you didn't know that, you could divide. -6 divided by 2 is -3. 18 divided by -6 is -3. -54 divided by 18 is -3. So you are multiplying by -3. That makes this geometric. It's geometric. A1 is 2, and R is going to be -3. That's the number I'm multiplying by. Okay, so for my formula, I'm going to use my geometric formula that I have up here. AN is equal to 2 times -3 to the n minus 1 power. And then if I want A7, I'm going to plug 7 in for n. So I'm going to write 2 times -3 to the 7 minus 1. There's a minus sign in there. So that's going to be 2 times -3 to the 6th power. Okay, and 2 times -3 to the 6th power is 1458. Okay, so that is your value for the 7th term, 1458. All right? Okay, hopefully you got that one. Let's try numbers 5 and 6. So for number 5, we have 6, 18, and 30. So 6, 18, and 30. It looks like what I'm doing is, might look like you're multiplying at first. 6 times 3 is 18, but 18 times 3 is not 30. So it looks like you're adding. So you're adding 12, right? 6 and 12 is 18. 18 plus 12 is 30. Yep, that makes this arithmetic. So A1 will be 6. D will be 12. Remember, it's arithmetic, so it has a common difference. The formula for an arithmetic sequence is AN equals A1 plus n minus 1 times D. So my formula here is going to be AN equals 6 plus n minus 1 times 12. And then to find A10, I'm going to put a 10 in for n. So I'm going to have 6 plus 10 minus 1 times 12. So that's going to be 6 plus 9 times 12. So that's 6 plus 108, which is 114. So A10 is going to be 114. And finally, number 6, we have 128, 64, and 32. Okay, so let's say I didn't know what that was. So I could divide. So I'm going to do 64 divided by 128. If you type in 64 over 128, you get 1/2 or 0.5. If you do 32 divided by 64, you get 1/2 or 0.5. So this must be geometric, and R is 0.5 or 1/2. Either way, you are multiplying by 1/2 or 0.5. Same thing. Okay, so your formula for a geometric sequence, let's put it down here where we have a little room. AN would be A1 times R to the n minus 1 power. So AN is going to be A1, which is going to be 128. That's A1, 128, first term, times 1/2 or 0.5 to the n minus 1 power. And then A9 would be 128 times 1/2 to the 9 minus 1. So that's 128 times 1/2 to the 8th power. And that will be 1/2, or 0.5. So the 9th term in this sequence is going to be 1/2, or 0.5. Okay? So again, what I want you to understand is that if you have a geometric sequence and you know you're multiplying by something to get from one term to the next, or you're dividing and you're not sure what number you're multiplying by, divide the next term by the one before. 64 divided by 128, or you could do 32 divided by 64. It should give you the same answer every time, and that will tell you that it's geometric. Okay? All right, so we have one more to go. We're going to work on this one on the bottom that has the chart. Okay, the one on the top we're not going to work on today. It asks you to use the table at the right to answer the questions below. Use the table to the right to write the explicit formula of the geometric sequence. So in week 1, there's 2 mathletes. Week 2, there's 6. Week 3, there's 18. Week 4, there's 54. Week 5, there's 162. All right, so let's see. It's geometric. So if I divide the one after by the one before, it should give me the common ratio. So 6 divided by 2, that's 3. 18 divided by 6, that's also 3. 54 divided by 18, also 3. 162 divided by 54, also 3. So I must be multiplying by 3. And sure enough, I am. Right? You probably figured that out without doing the division. But just in case, the division always works. Okay, so you're multiplying by 3 to get from one term to the next. So that makes A 1, 2, and R is 3. So here's our rule. We're going to write it down here under part B because we're running out of room. So our rule for a geometric sequence is AN equals A1 times R to the n minus 1 power. So that's going to be 2 times 3 to the n minus 1 power. That's going to be AN. Now, in week 11, that would mean I'd want to find A11, the 11th term. So I'd have to put 11 in for n. So A11 is 2 times 3 to the 10th, and that makes A11 118,098. If you type it into a calculator, that will give you 118,098 mathletes. All right, that is your 11th term. In the 11th week, there'll be 111,098 mathletes in the program. Okay, now over here, it says based on the graph, what kind of function is this? So I want you to make the graph. Okay, so we're going to graph these. All right, so this is 1, that's 2, 3, 4, and 5. Some of these are not going to fit on the graph, but we're going to do the best that we can. In week 1, there are 2 mathletes. Okay, so this going up, it's 20 as you reach the 4th box. So it's 5, 10, 15, 20. So each one of these little lines here is 5. All right, so that'll give us an idea. So we're going over to 1, up 2. So just barely above 0. Over to 2, up 6. So above the 5 there. Over to 3, up 18, up to here. Over to 4, up 54. So let's see. That's 40, that's 60, so this is 50, 54. And then over to 5, we'd have to go up 162. That's way higher. Okay, that would be way up here somewhere at the top of the slide. And now, if we take a look at what we have, we don't have something, well, we're not going to connect the points because it's a sequence, and you're not supposed to connect the points. Okay, there are no numbers in the middle. You can't find the 1.5 term. Okay, you can't find the 1.6th term. That doesn't make sense. First term, second term, third term, fourth term, it's a list of numbers. All right, so we're not going to connect the points. But if we were to, you can see that what we have here, it's not a line anymore. Okay, it's certainly not a line. And what it is, and hopefully you remember from when we talked about it way, way back, is this is an exponential function. Okay, this is an exponential function. And that should make sense, I guess, because if you look at the formula has an exponent in it, right? R to the n minus 1. So that makes this exponential. And that's what we're going to be talking about here later on in this chapter, exponential functions. Okay? All right, so that's it for your lesson on geometric sequences. And as always, thanks for clicking.